So next I will give you an idea about the problems involving the traces of the line. So traces of the line, there are two traces are there, horizontal trace and vertical trace. And traces are the points of intersections of a line or the extension of a line with respect to reference planes. A line itself or its extension wherever touches HP, that point is called the horizontal trace. If a line is extended, then if that line touches the horizontal plane, then that point will be the horizontal trace. Similarly, a line itself or its extension wherever touches vertical plane, that point is called trace of the line on vertical plane. It is called vertical trace. If a line is extended, then that line will be touching vertical plane to a point, then that point is called the vertical trace. And the vertical trace is actually a point on the vertical plane, and horizontal trace is a point on the horizontal plane. If the vertical trace is a point on the vertical plane, if a point is on the vertical plane, we know that the top view will be on the reference line, XY line, and the front view will be that point itself. And the horizontal trace is a point on the horizontal plane. So we know that if a point is on HP, its front view will be on the reference line, and the top view of the horizontal trace and the horizontal trace will be the same point. How to locate the horizontal trace and the vertical trace? See, this is the front view and top view. First of all, we just extend the front view to the reference line. That point will be H dash. H dash means the front view of the horizontal trace. Draw a perpendicular line through H dash and then extend the top view. And our top view will touch the perpendicular through the point H dash. Then that point is called the horizontal trace. So this point is the horizontal trace. So remember, the H dash and HT will be on the same straight line. And then how to locate the vertical trace? Extend the top view and it will touch the reference line, then that point will be the small letter V. Small letter V is actually the top view of the vertical trace. Draw a perpendicular line through V and then extend the front view. That front view will touch that line. That point is called the vertical trace. So the vertical trace VT and V will be on the same reference, same projector line. And you can see that the vertical trace H dash and the front view will be in a single straight line, and the V, HT and the top view will be on the same line. So this is very important. Points H dash and V always on reference line, XY line. H dash means the front view of horizontal trace and V means the top view of the vertical trace. VT and V always on one projector, HT and H dash always on one projector, and front view H dash and VT that always collinear. Top view V and HT are always collinear. So this is very important. So this is the question. The front view of a line AB makes 45-degree angle with XY line and measures 60 millimeter, which means the front view of the line is 60 millimeter, and the front view makes an angle called alpha. So alpha is 45 degree, and lines top view makes 30 degree with the XY line. So the top view makes an angle of 30 degrees, so beta is 30 degree, and A is 15 millimeter above HP. Point A is 15 millimeter above HP, horizontal plane, so it will be in first quadrant or in second quadrant, and its vertical trace is 10 millimeter below HP. So the vertical trace is 10 millimeter below HP, which means the vertical trace will be on the vertical plane, and it will be 10 millimeter below HP. And draw the projections of the line AB and determine the inclinations with HP and VP. So theta and phi should be found out, and locate the horizontal trace and the vertical trace. So first of all, I just draw the reference line, XY line, and then mark the first point A dash. We know that point A is 15 millimeter above HP, so I draw the mark the point A dash 15 millimeter above HP, and then take angle 45 degree. Alpha is 45 degree, and this angle is 45 degree, and draw the front view. And the length of the front view is 60 millimeter, so this point is B dash, and the vertical trace is 10 millimeter below HP. So I draw the locus line of the vertical trace, and we know that if when we extend the front view to the reference line, that point is called H dash. So mark H dash, and we know that the vertical trace is 10 millimeter below HP, so that line is extended, and that line touches the 10 millimeter line below XY, so that point is called vertical trace. So draw a perpendicular line through vertical trace, that point is called V. And we know that the top view makes an angle of 30 degree with XY line. So through point V, draw a line with angle 30 degree, and the projector from A dash will touch that line, that point is called A, and draw a projector line through point B dash, it will touch this point B. So join A and B, this is the top view, and then draw a perpendicular line through H dash, and it will touch the extension of the top view, that is called HT, horizontal trace. So this is the horizontal trace HT, and draw the two locus lines, and then I rotate the point B and make parallel with the reference line. So and then project it, and you will get the true length. This point is B1 dash, join A dash and B1 dash, it will be the true length, and this angle is called theta. This is true inclination with horizontal plane HP. Then once you get the true length, and just in compass take the true length and the center A and cut the below locus line, you will get point B1. So this is actually true length, and this angle is called phi. This is true inclination with VP. And the next question is, one end of line AB is 10 millimeter above HP. So AB is a line, and one end point, say point A, is 10 millimeter above HP, which means the point A is either in first quadrant or in second quadrant, and the other end is 100 millimeter in front of VP, and the second end point is 100 millimeter in front of VP, which means the other end point is either it is in first quadrant or it is in fourth quadrant. Its front view is 45 degree inclined to XY line. Front view makes an angle called apparent inclination alpha. So alpha is 45 degree, while its horizontal trace and vertical trace are 45 millimeter and 30 millimeter below XY respectively. So its horizontal trace and vertical trace, horizontal trace are 45 millimeter below XY line, and vertical trace also 30 millimeter below XY line. So draw the projections and find the true length and the inclinations with horizontal plane and vertical plane. So first of all, draw the reference line XY line, and mark the first point. We know that the point A is 10 millimeter above HP, so I just mark A dash 10 millimeter above HP, and we know that the front view is 45 degree with the XY line, so I just draw a line with the angle 45 degree, but I don't know the length of that line. But I know another thing, The vertical trace is 30 millimeter below XY line, and the horizontal trace is 45 millimeter below XY line. So I draw the two lines of the first line is 30 millimeter below XY line, and the vertical trace will be on that line. So I don't know where it is. So that 30 millimeter line, the vertical trace will be on that line, and the horizontal trace will be below 45 millimeter line. Then I just extend my front view, and we know that when I extend my front view, it will touch the reference line. That point is called H dash. So this point is H dash, and it will touch the line. So this is vertical trace, because we know that the vertical trace is 30 millimeter below XY line. So this point is vertical trace. Draw a perpendicular line through vertical trace. It will meet the XY line. That point is called V. So this is the top view of vertical trace V. Then draw a perpendicular line through H dash. It will touch the 45 millimeter line. That point is called the horizontal trace HT. And we know that the second point is 100 millimeter in front of VP. So this is the locus of B and B1. Then we just join the point V HT and extend it. So it will touch the locus line also, and also the projector line from A dash. So the projector line from A dash will meet that line. That point is called A, and the it will extend, it will touch the locus of B. That point is called B. So AB will be the top view, and when you get the point B, you just project it, you will get B dash. So this point is B dash. So A dash B dash will be the front view, and AB will be the top view. So this is the front view and top view. So once you get the front view and top view, draw the two locus line. Draw the locus line through point B dash. So this is B dash and locus line of B dash and B1 dash, and then draw a line parallel to the XY line through point A. Then I rotate the top view. I fix my point A and rotate the point B, and then project it through the first locus, and that point will be B1 dash. Join A dash and B1 dash. That will be the true length. Then the true length makes an angle called a theta. So this angle is called a theta. True inclination with HP. This is true length. Once you get the true length, take that true length in the compass, and with the center A and cut the bottom locus line, you will get point B1. So this point is B1. Join A and B1. This is also true length, and that true length makes an angle called phi. So this angle is phi. This angle is phi. And next question is, projectors drawn from horizontal trace and vertical trace of a line AB are 80 millimeter apart, and those drawn from its ends are 50 millimeter apart. So the projectors drawn from horizontal trace and vertical trace of a line AB are 80 millimeter apart. So the distance between the projector lines from HT horizontal trace and vertical trace will be 80 millimeter apart, and those drawn from its ends are 50 millimeter apart. So a distance between the end projectors are 50 millimeter apart. So end A is 10 millimeter above HP, point A is 10 millimeter above HP, which means the point is in either it is in first quadrant or in second quadrant. The vertical trace is 35 millimeter below horizontal plane. The vertical trace is 35 millimeter below HP, while its horizontal trace is 45 millimeter in front of VP. The horizontal trace is 45 millimeter in front of VP. Draw the projections and locate the traces. Traces means the horizontal trace and vertical trace, and find the true length. What about the true length? And inclinations with HP and VP. Inclinations means theta and phi. So first of all, draw the reference line, XY line. So this is my XY line. Then draw two projectors. So the two projectors, distance between the two projectors are 80 millimeter. The two projectors are the projectors of the horizontal trace and vertical trace. And so this is the first projector line. So this is the horizontal trace. We know that the horizontal trace is 45 millimeter in front of VP, and the vertical trace is 35 millimeter 35 millimeter below HP. So this is actually draw two projector lines, and one projector line is the projector line of horizontal trace, and the second projector line is the projector line of the vertical trace, and that the distance between that two lines are 80 millimeters. So this is shown in the figure. And then draw the locus of A dash. We know that the A dash will be 10 millimeter above HP, so I just draw the locus of A dash, and that locus of A dash will touch that point on the line H dash VT. So this point is A dash, so this is A dash. Once you get A dash, draw the projector through A dash, and it will touch the line VHT, so that point is A. So this is end projector, one end projector, and in the question you see that distance from the end projectors are 50 millimeter apart. So from this line, projector line A dash A projector line to the B dash B projector line, the distance will be 50 millimeter apart. So draw the second projector. So this is 50 millimeter apart. So this point is B dash, and the bottom point is join A dash and B dash, it will be the front view, and this point is B, join A and B, it will be the top view. And draw the locus line through point B dash and B, and then I fix the point A and rotate the point B and make parallel with the reference line, and then project it into the first locus. This point is B1 dash, join A dash and B1 dash, it will be the true length, and the true length makes an angle of theta. So this angle is true inclination with HP. Once you get the true length, take that length on the compass and with A center, and cut the locus below XY line, and this is the true length, and this point is called a B1, and this line makes an angle of 5 degree with VP. So this angle is called true inclination with VP. So this is true length, and the front view, true length, theta, phi, all things will be displayed in the figure. So from the figure you can see that the horizontal trace is the horizontal trace and vertical trace all are shown in the figure. See, this is the front view and top view of a line inclined to both HP and VP. So when I extend the front view, you will get the horizontal trace and vertical trace. So that construction will be also explained in the earlier slides. Then when we rotate fix the point A dash and rotate the B dash, so this will be another case. Instead of considering A and A dash as projections of first point, V and VT are considered as first point. Then true inclinations of the line with HP and VP, that is angles theta and phi, can be constructed with points VT dash and V respectively. Then from point V and HT, angles beta and phi can be drawn, and from point VT dash and H dash, angles alpha and theta can be drawn. So line AB is 100 millimeter long, so true length is 100 millimeter, and it is 30 degree with HP, so theta is 30 degree, and 45 degree with VP, so phi is 45 degree, and A is 10 millimeter above HP, which means the point A is either it is in first quadrant or it is in second quadrant, and its vertical trace is 20 millimeter below HP. So draw the projections of the line. So first of all, I mark the vertical trace VT, and V on the reference line. The vertical trace is 20 mm below HP, and I just marked that the locus of the vertical trace 20 mm below HP, and the point A is 10 mm above XY line. So I draw the locus of A. Then I draw a line through VT dash with an angle of theta degree, and that line will touch the locus of A, and you will get the point A1 dash, and take the true length 100 mm and mark the point B1 dash. Then through point V and with angle 45 degree draw the second line and mark the point A1 B1. It is also true length 100 mm, and then draw the locus line through point B1 dash and project B1 and rotate it. So this point is B dash. So join B dash and the vertical trace, then you will get the point A dash. So once you get the point B dash, draw the projector line to the second locus. This point is B, then join B and V. So this will be the, then project the line through point A dash and it will touch the VB line, then that point is called A. So you will get the front view. The red line indicates the front view. A dash B dash will be the front view and AB will be the top view. And the horizontal trace, once you extend the front view, you will get the horizontal trace H dash. Draw a perpendicular line through H dash and then extend the top view, you will get the horizontal trace HT. Problem number 10. A line AB is 75 mm long. The line is 75 mm long. True length is 75 mm. Its front view and top view makes 45 degree and 60 degree inclinations with XY line. So alpha is 45 degree and beta is 60 degree. And A is 15 mm above HP. So the point A is either it is in first quadrant or it is in second quadrant. And the vertical trace is 20 mm below XY line. So line is in first quadrant. So if a line is in first quadrant, its front view will be above XY line and top view will be below XY line. Draw the projections and find inclinations with HP and VP. So theta and phi should be found out, and also locate the horizontal trace. First of all, draw the reference line XY line and mark the trace, the vertical trace VT and V. Draw two locus line. The vertical trace is 20 mm below XY line, and I draw the locus through the vertical trace, and the point A is 15 mm above HP, so I draw the locus of point A. So this is point A. Then I just draw a line through point VT, and this angle is 45 degree, and I will get the point A dash. So this is point A dash, and through point V draw another line with angle 60 degree. The beta is 60 degree, and then I draw a projector line through point A dash. It will touch the line from point V, so that point is A. So I will get the point A dash and A. Then I rotate the point A dash, and you will get the point A1. So join V and A1 and extend it, and from A1 take the true line 75 mm, mark the point B1. So draw the locus line through point B1. Then after drawing the locus of point B1, you will get point B. Join A and B, it will be the top view. Then project the point B1 and then rotate it. You will get the point B dash, and B dash and B will be on the same projector line, and A dash B dash will be the front view. Draw locus line through point B dash, and then draw a line from the vertical trace VT dash, and we'll get the true length, the A1 dash B1 dash, that will be the true length 75 millimeter, and this angle is theta. True line makes an angle with HP that is called true inclination with HP, so that angle is theta. And the phi means the line true inclination with VP. True length makes an angle with VP, so A1 B1 makes an angle with VP, that is called phi. So theta and phi will be shown in the figure. And also once when you extend the front view, it will touch the reference line, that is called H dash. Draw a perpendicular line through H dash and extend the top view, you will get the horizontal trace, and H dash and HT will be on the same projector line. Question number 11. The projector is drawn from vertical trace and end A of a line AB are 40 mm apart. So the projector line from vertical trace and end A are 40 mm apart. End A is 15 mm above HP and 25 mm in front of VP. So point A is in first quadrant. The vertical trace of line is 20 mm below HP. So the vertical trace is 20 mm below HP. If the line is 75 mm long, which means the true length of the line is 75 mm, draw its projections and find the inclinations with HP and VP. So theta and phi should be find out. So draw the reference line, XY line, and first of all draw the distance between the projectors of vertical trace and A. So the line A dash and A, that is the projector of point A, and the second line, that is the projector of vertical trace. So the distance between that two will be 40 mm. So this are 40 mm, and draw two lines through the vertical trace and the A dash and also A. So A dash will be, we know that A dash is point A is 15 mm above HP, so A dash will be 15 mm, and the vertical trace is 20 mm below HP. So this is the vertical trace 20 mm below HP, and the point A is 25 mm in front of VP. So this is the top view of point A. Then join VT and A dash and V and A. Draw a locus line through point A dash, and then I rotate the point A and project it. You will get point A1 dash, and join VT and A1 dash and extend it, and from A1 dash you will take the true length. So this is 75 mm. You will get the point B1 dash. So draw locus line through point B1 dash and mark the point B dash. So you will get point B dash on that locus line, and A dash B dash will be the front view. And then once you get the front view, you just project through point B dash and then extend the line VA, and it will touch that line. That point is called B, and AB will be the top view. Draw locus line through point B and also through vertical trace. Then rotate the point B dash and project it to the second locus. That point will be B1. Join V and B1 and that angle called phi. So next case is cases of the lines in auxiliary vertical plane, auxiliary inclined plane, and profile plane. So this is the horizontal plane and vertical plane. Auxiliary inclined plane is a plane which is perpendicular to the vertical plane and inclined to the horizontal plane, and the angle, the alpha, so you can see that angle alpha. So this plane is inclined at an angle of alpha degree to the HP. So if a line AB is in auxiliary inclined plane, its front view A dash B dash is shown projected on VP, and here you can see that inclination of auxiliary inclined plane with HP is equal to inclination of the front view with the reference line. And consider the auxiliary vertical plane. Auxiliary vertical plane is a plane which is perpendicular to the horizontal plane and inclined with the vertical plane. So the angle is beta degree. So if a line is in auxiliary vertical plane and the top view, you will get the top view. So this is the top view, and top view and that line makes an angle of beta degree with the reference line. So line AB is in auxiliary vertical plane. Its top view is shown projected on horizontal plane. Here you can see that the inclination of auxiliary vertical plane with the vertical plane is equal to the inclination of the top view with XY line. And the next case is line in a profile plane, means a line, a plane which is perpendicular to both HP and VP. So this is the vertical plane and horizontal plane mutually perpendicular. So the third plane is a profile plane. This plane is perpendicular to both HP and VP. And if a line on the profile plane, so AB is a line on the profile plane, and the front view, you will get the front view will be A dash B dash and top view will be AB. So this is the orthographic projection in a profile plane. Profile plane is used to get the side view of an object. So front view you will be getting on the vertical plane, top view you will be getting on horizontal plane, and you will get side view on the horizontal plane. So after getting the side view on the profile plane, we just rotate the profile plane on the right side or on the left side. So here from the left side you can see the profile plane, and in the orthographic pattern you can see the profile plane is on the right side, and that view will be the left side view. So left side view will be on the right side of your drawing sheet. So this is the vertical, this is the front view, A dash B dash, and this is the top view, and these you just project it, and the top view you just project it into the line which intersection of the profile plane and vertical plane, and then rotate it and then project it. You will get two different points, and the side view will be represented by A double dash and B double dash. So this is the front view and top view, and this is the left side view. Left side view will be on the right side of the drawing sheet. And when I extend this is the horizontal trace, and when I extend the line, this is the vertical trace, and this angle is alpha theta, the bottom angle is theta, and the top angle is phi. It will be very clear in this the pictorial representation. So this is another problem. Line AB is 80 mm long, so true length is 80 mm, and makes an angle of 30 degree with the horizontal plane. So HP theta is 30 degree and lies in an auxiliary vertical plane, 45 degree inclined to VP. Auxiliary vertical plane is a plane which is inclined to vertical plane, and that angle is called beta. Beta is 45 degree. And A is 15 mm above HP. So A is either it is in first quadrant or second quadrant, and the vertical trace is 10 mm below XY line. So draw the projections and find the angle with the VP and HD. So first of all I mark the vertical trace, and the point is 15 mm above HP, so I draw the locus line of A and also the locus line of vertical trace, so that is 10 mm below XY line. Then draw the line through point vertical trace and makes an angle of theta, and that line will touch the locus line of A, will get point A1 dash, and you know that the true length will be 80 mm, and A1 dash B1 dash will be the true length, and that will be 80 mm, and mark the point B1 dash, and the locus of point B dash is marked. And then once you gets the point B1 dash, and then project it and then rotate it, you will get the locus point of B, and then through point B I just project it, you will get point B dash, and join B dash and VT, and you will get the point A dash, and A dash B dash will be the front view, and after that I project the point A dash, I will get the point A, and AB will be the top view. When I rotate the point B dash and project it to the second locus, that point is called a B1. And we know that the auxiliary vertical plane is 45 degree to the VP. So a line is so this is another line. This is the case in which the line is lying in the reference plane, in the profile plane. So this is the case. This is a line on the profile plane. So this is the line, and that this is the side view. Once I get the side view and then rotate it, you will get the front view and top view. So this is the side view. Side view will be the true length, and the front view and top view will be the apparent length. And the applications of principles of projections of lines. So different cases will be there, application problems. So one application is that two objects, one a flower, A is a flower and B is an orange, are within a rectangular compound wall. You can see whose P and Q are walls. Wall P and wall Q are shown in the figure, are meeting at 90 degree perpendicular to each other, and flower A is 1 meter and 5.5 meter from walls P and Q respectively. So consider the flower A as a point. So point A is 1 meter from wall P and 5.5 meter from wall Q. And the orange B, consider another point. So B is another point which is 4 meter from wall P and 1.5 meter from point Q. Then draw the projection of this and find the distance between them. What about the distance from the flower A to orange B? If the flower is 1.5 meter and orange is 3.5 meter above the ground, consider suitable scale. So consider the point, join the line, join the point A and B. You will get the line AB, and with the principle of line you can easily solve this problem. And second question is two mangoes on a tree. So A and B, mango A and mango B, are 1.5 meter and 3 meter above the ground. So mango A is 1.5 meter above the ground and mango B is 3 meter above the ground, and those are 1.2 meter and 1.5 meter from a 0.3 meter thick wall but on opposite sides of it. If the distance measured between them along the ground and parallel to wall is 2.6 meter, we'll find the real distance between them by drawing their projections. So again, this is the previous case. Again, this is another problem. OA, OB and OC are three lines, and OA is 25 millimeter, OB is 45 millimeter, and OC is 65 millimeter. All are equally inclined, and the shortest is vertical. This figure is a top view of three roads, OA, OB and OC, whose ends A, B and C are on ground, and end O is 100 millimeter above ground. Draw their projections and find length of each along with their angles with ground. And the next, another application problem. A pipeline from point A has a downward gradient 1:5 and it runs due east-south. Another point B is 12 meter from A and due east of A and in same level of A. Pipeline from B runs 20 degree due east of south and meets pipeline from A at point C. Draw projections and find length of pipeline from B and its inclination with the ground. Again, this is another application problem regarding line. A person observes two objects A and B on the ground from a tower 15 meter high at the angles of depression 30 degree and 45 degree. Object A is due northwest direction of observer and object B is due west direction. Draw projections of situation and find distance of objects from observer and from tower also. So again, this is another application problem. Guy ropes of two poles fixed at 4.5 meter and 7.5 meter above ground are attached to a corner of a building 15-meter high. Make 300 and 450, 30-degree and 45-degree inclinations with ground respectively. The poles are 10-meter apart. Determined by drawing their projections, length of each rope and distance of poles from the building. Again, this is another problem. A tank of 4-meter height is to be strengthened by 4 stair rods from each corner by fixing their other ends to the flooring at a point 1.2 meter and 0.7 meter from 2 adjacent walls respectively as shown. Determine graphically length and angle of each rod with flooring. Again, this is another application problem. A horizontal wooden platform 2 meter long and 1.5 meter wide is supported by 4 chains from its corners, and chains are attached to a hook 5 meter above the center of the platform. Draw the projections of the objects and determine length of each chain along with its inclination with the ground. And another typical problem, a room of size 6.5 meter length, 5.5 meter d, 3.5 meter height. An electric bulb hangs 1 meter below the center of the ceiling. A switch is placed in one of the corners of the room 1.5 meter above the flooring. Draw the projections and determine the real distance between the bulb and switch. And another thing, a picture frame 2 meter wide and 1 meter tall is resting on horizontal wall railing, makes 35-degree inclination with wall. It is attached to a hook in the wall by 2 strings. The hook is 1.5 meter above wall railing. Determine length of each chain and true angle between them. So these application problems, you just think and solve it with the help of all the problems discussed earlier. And solve the application problems. See the application problems, this is very important. Solve the application problems, the flower and orange problem, the problem related to mango, and this problem pipeline, and the regarding the tower, poles and tank, wooden platform, room, picture frame. So all this application problems you will solve according to the explanations above.